Pre-Calculus Chapter 6, and in this lesson, or portion of the lesson, we want to look at resolving a vector, the final piece that we put before we start applying these to some real-world types of situations. We've looked at adding vectors together using component form. We've looked at determining the magnitude and the unit vector. There is another way to represent the vector, and that is by giving the vector's direction as an angle measurement and then giving its magnitude, and this is sometimes called resolving a vector. Now, direction, you remember, can be measured in different ways using different reference points depending upon the context. You remember, if we're talking about an angle measure given in terms of navigation, we have to measure from due north, and we measure east of north or west of north depending upon what we're given, but we measure given from the north direction. In trigonometry, you remember, we measured starting with the positive x-axis, and a positive angle rotates counterclockwise, a negative angle rotates clockwise. And the tie between vectors and trigonometry is the fact that when we're given an angle measure of a vector, we're going to begin with the positive x-axis as well. So when we give an angle measure of a vector, it's always going to be measured from the positive x-axis. So rather than giving component form of the vectors, we want to give the angle measure and the direction, or the magnitude, the angle measure gives me the direction, and then the magnitude of the vector will give me the length of the arrow. Well, that gives me another way to represent a vector other than component form. Now, there's one little formula, or one thing you need to know, and that's this. That if you have a vector v, the a component of the vector is equal to the magnitude of the vector times the cosine of the angle. The b component is equal to the magnitude of the vector times the sine of the angle. And again, you kind of see how these line up with the cosine being the x and the sine being the y, as we talked about in trigonometry. So we actually have two little formulas in one here. The a component is equal to the magnitude of the vector times the cosine of theta. Now, these are three variables, and as in any equation, as long as I know two of the variables, or I know their values, I can calculate the other one by using my algebra skills. The b component then is equal to the magnitude of the vector times the sine of the angle. And either of these formulas, or both of these formulas, will be used to determine the component given the direction, angle, and the magnitude. Or if I'm given this form, I can figure out what the components of the vector and give the component form. I should be able to go either way with these. So let's do a couple of examples. For our first angle, we have a vector represented here by a 55-degree angle and a 14 magnitude. The question is, what are the components? Or that's resolving the vector. So what are the components? What is the a and the b of this point right here? And hopefully you'll see that if you draw this down, we're simply applying trigonometry. Opposite over hypotenuse gives me the y value, the sine. Adjacent over hypotenuse gives me the x value. Okay, so the a component, as we said, is equal to the magnitude, which I'm given here, 14 times the cosine of the angle, 55. The b component is the magnitude times the sine of 55. So again, hopefully you see the connection between all we're doing is drawing a triangle and applying our trigonometry skills. So when we do this, we have the components 8.03 and then 11.47. Let's take a look at another example. Again, I think hopefully if you see this graphically, you're getting a picture of how this is not really too difficult. Let's see, you got this one here. Okay, now this one's just a little bit more difficult because my angle is outside, but again, if I draw this, we know that this sine and cosine of this angle inside is the same as the sine and cosine of this 108-degree angle, because any angle that has this as its terminal side, the sines and the cosines are going to be the same. But rather than going through the process of drawing my right triangle, figuring out what the measure of this angle is, and doing that, I can simply use what I know about the vector arithmetic, that the a component is equal to the magnitude, here which is given as 47, times the cosine of the angle, which is 108. And that will give me my a component. The B component is the magnitude times the sine of the same angle. And so all I have to do is calculate those values, and I come up with negative 14.52, which makes sense because I'm going left, and then up 44.7, which again makes sense because I'm going up. So you want to make sure that your values make sense as to what you're doing, because remember, you're finding the coordinate of this point. In order to get to that point, I have to go negative, so a negative value makes sense, and then I'm going up, so a positive value makes sense as well. Very quickly, let me show you one more example. So in this example, again, we have a magnitude of 18 and an angle of 25. So the A component is the magnitude times the cosine of the angle, and the B component, again, is the magnitude times the sine of the angle. If we calculate those, we come up with 16.3, a positive number, which makes sense, and 7.6, a positive number, which also makes sense. Now again, hopefully you realize that the arithmetic of this is fairly easy. The challenging part becomes then when we're reading a word problem or applying the problem is making sure that we gather the correct information from the problem, put it in the correct place in our formula, and then simply do the arithmetic. One final example that we'll need to do is now we know how to go from component form to the direction and magnitude form. How do we go the other way? In other words, I'm given the components. Now how do I determine what the direction angle is and then the magnitude? Well, the magnitude we already know how to do. That's the square root of the a squared plus the b squared, so that gives me a square root of 13. So all I have to do is figure out what the direction is. Well, if I think about this, here's the point 3, 2 out here, over 3 up 2, here's this. So this is the angle that I'm interested in. What is it? Now, I know that the A component is equal to the magnitude times the cosine of theta, and the B component is equal to the magnitude times the sine of theta. Now, I know the magnitude, and I know A and B, so all I need to know is the angle. So actually I can use either one of these equations to solve for the angle, substituting in either the A component and the magnitude or the B component and the magnitude. So I'm going to go ahead and use the A component. So what is the A component? Well, the A component is a 3. So 3 is equal to the magnitude, which I now know is the square root of 13, times the cosine of theta. Now how do I solve for the cosine of theta? Well, first thing I do is I divide by square root of 13, so that's 3 over the square root of 13. And then how do I find the angle that has this? We use the inverse function. So this is going to be the inverse cosine of 3 over the square root of 13. That's going to give me the measure of my angle. Okay, so now that I've calculated all that, or that's the exact answer, to calculate that, I come up with an angle of about 33.69. So the magnitude of my angle then is the square root of 13. That would be, well, not quite that. The magnitude would be the square root of 13, and then the direction angle would be about a 33.69 degree angle. So again, going up this way, this would be about a 33.69, and the magnitude would be a square root of 13. So resolving a vector is finding the trigonometric components. A is equal to the cosine, or magnitude cosine theta. The B component is magnitude sine theta. And then you have these two equations, and you can just go either way, whatever one you're trying to determine.